people? 3 people? Anyone else? This first one, what kind of problem is it? Everyone else is left. All left the building. Okay, this one is ANOVA. We know it's ANOVA because it has 3 lists. There is, so let me do this. There's categories here or labels here, but there are no labels there. So it can't be a matrix. You might look and say, oh, it looks like there's, looks kind of like a matrix, but there's no data, there's no labels on the side, so it cannot be a matrix. Without that, you can't have it. It's got to be both the top and the side. So how about the one below it? Take a look at the one below it. What kind is that one? I don't know why I can't get my chat up. That's not helpful. Oh, I know what happened. Okay. Okay. So again, this one also is, there are categories here and categories there. So this one's a matrix. This is the chi-squared matrix. My computer doesn't like me. Chi-squared matrix. Okay, and then how about the last one, the bottom one? What's that one? So, oh good, I have you guys back again. All right, so yes, it's a chi-squared list because we have stuff along the side and the top, so it's one of the chi-squareds, but what's along the side is observed and expected. So this one is just a chi-squared list. And then how about this last one up here, the one we haven't done yet? So I have labels here, but I do not have labels there. So it can't be a chi-squared. It can't be a chi-squared because I don't have anything, I don't have labels over here. I'd have to have labels on both. Do you know what I'm saying? Especially the long way, right? The long direction, I have to have labels here, and there aren't. So it can't be a chi-squared. So if it can't be a chi-squared, has to be either ANOVA or chapter 10, and there aren't 3 or more lists, there's only 2. So then we have our X, you see our, oh, there's our X and our Y, this is chapter 10. So that is our correlation regression. Okay, good, questions? Everybody all good? Not that I could see if you had questions. Okay, go, good, perfect, thank you guys. All right, so what kind of problem is this one? Is that you guys chatting and I just can't see it? I can't see you, so I'm going to assume you guys are talking. And I'm assuming that you're saying that, well, there's categories up here. There's labels there and there's labels there. So I have labels on top and labels on the side. If I have labels on the top and the side, that has to be a chi-squared matrix. There's no other choice. Has to be. So this is chi-squared matrix. Next one. How about this one? What kind of problem is this? Okay, so linear correlation. There are things here, but there aren't anything here along the long ways. So it can't be a chi-squared. So this chi-squared has to have something along the long ways, and ideally it has to have the top and the top and the side. So this is not a chi-squared. So that means it has to be either ANOVA, which doesn't kind of make sense because ANOVA would have 3 or more lists. It's only 2. And you also notice it says linear correlation. So that is another hint that it is chapter 10. That's my X and my Y. Okay, take a look at this one. What did you guys come up with? So again, there are categories here, labels here, but no categories there. So it can't be a matrix. It looks like a matrix, but it can't be a matrix because there are no categories along the side. So then we look and, oh look, it says mean right there. Right, so anytime it says mean, that's got to be ANOVA. Automatic ANOVA. Okay, last one. Maybe if I do this. Hold on. Sorry, guys. Uh-oh. That one? No. That one. There we go. Now I can see you. Look at you guys. I can see your chat now. Okay, go ahead. Tell me. So I've heard from 3 people, 4 people, 5 people. One of them's wrong. So, all right, so let's talk about things. So PPMC would be where you have an X and a Y, and they match up. So I'd have to have X's and Y's. I don't have that one. I'd have to have something that looks like. I'd have to have something that looks like, oops, like this, right, with data. And then ANOVA, I'd have to have 3 separate lists. So I'd have to have 3 or more lists of data. I don't have 3 or more lists. I only have, as far as I can tell, I only have 1 list. So this one would be a chi-squared list. So here, what are my labels? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Those are my labels. And then these numbers here, those are my observed. So they go into the list. And then I have to calculate the expecteds. This stuff is kind of hard, isn't it? So what I really want you guys to do is practice, right? So there's, like I said, there's this, if you go to the study guide, practice exam study guides in Canvas, that page, then the very bottom, you have the finals review type of problem, chapters 7 through 11. Those are all mixed between chapters 7 through 11. And try to figure out what kind of problem it is, and then take a look and see if you got it right from the solution, and try to work through those and figure them out, because it's hard, and it's going to be the toughest part of the exam is figuring out. Toughest part of ANOVA is recognizing that it's ANOVA. Doing an ANOVA is super straightforward. It's not difficult at all. Okay, so what we're going to do is we're going to work on this problem. So go ahead and take a picture of this problem. We're going to do it after break. So take a picture of it now, because I'm going to stop sharing this, so in like 5 seconds, or I'll put it back up afterwards so you could take a look at it afterwards if you want. Okay. And let me Here's the problem.
Oh.
Yes. Question?
Hello?
Hello. Oh. We're all back. Hey, before I forget, can you guys see this? Stop sharing.
Yeah.
This is my can of RC Cola. So that's how I remember row and column RC Cola. One of my students gave it to me long ago. Actually, not long ago, a couple years back. All right. Sorry, question? You had a question? Someone had a question? All right. So let's go ahead and take a look at this. So it is so there's two things going on. First is this one here. Is there sufficient evidence to conclude there's a linear correlation between court incomes and justice salaries? That is my hypothesis test. That's the first part. That's my 5 steps. Then I'm asking a second part based upon, if a court income is 1,000, predict the justice salary. So this is a separate section after the hypothesis test, part 2 kind of in a way. All right, so the hypothesis goes like this. Step 1, H0 is rho equals 0. H0 is rho equals 0. H1 is rho is not equal to 0. Step 2, find my critical value from the PPMC table. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs of data. My degrees of freedom is 9 minus 2, so that's 7. Don't think I was smart enough to, yeah, I was, okay. And again, it tells you right here, degrees of freedom is n minus 2, so it kind of helps you out. So it's point, and again, I didn't give you an alpha. Anytime you don't have an alpha, you should assume that it is 0.05. That's the default. So my alpha is 0.05, degrees of freedom 7, 0.666, that is my critical value. So I'm going to make a line, put in 0.66 shade to the outside, negative 0.66 shade to the outside. Then I'm going to bust out my calculator and put my data into a list, stat edit, put my x's into list 1, my y's into list 2. Make sure, please, please, please make sure you double check your numbers, because if you mistype one of these and it's really easy to do, everything's going to be wrong, and you just will be completely clueless about that. It's all kinds of trouble. Also, if you, for some reason, you have too many numbers, like maybe one didn't get cleared out from last time, so say this is 9 hanging out there from last time, and then I go ahead and I don't realize it, I do my stat test, Lin-Reg t-test, L1, L2, X is in L1, Y's are in list 2, frequency 1, or if you have a fancy calculator, then your frequency list, you leave that blank, not equal to, and then calculate. Dimension mismatch. That means my X's and the Y's, I don't have the same number of them. You'll also get that on your project if you didn't delete out the ones that have only an X or only a Y, because they have to match up. So I'm going to clear that. Let me go back over there. And then if I want to delete that one, I just want to delete one number, then you just hit the delete key and that deletes that one. Clears if you want to, you go up here and clear the whole thing, but delete just one number, you use delete. Stat, test, Lin-Reg t-test, bum, 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 all good. And then you guys got, well, here's your A, 27.70, write that down somewhere. There's your B, 0.03728, write that down somewhere as well. And then if you scroll down further, you get your R. There it is, 0.8643, 0.864. So I'm going to write down my R, 0.864, put it in here. Look, it's totally in the rejection region. So I'm going to reject H0, which means that I rejected H0, which means I have enough evidence to say there's a correlation between court income and justice salary. That is it. That's your hypothesis test. Now the second part was, if a court income is 1,000, predict the justice salary. So court income is 1,000. So what's court income? Is that my X or my Y? That is my X. So when X is 1,000, so when X is 1,000, predict the Y. So I'm going to put in 1,000 for X. let me go ahead and need to find my y. So here my y equals ax plus b. A is 27.0, b is 0.03273728, and then I'm gonna put in 1,000 for x. So 1,000 where the x goes, and you do all that, you end up getting 65 for your y.
Professor, I have a question.
Mm-hmm.
When we're doing the calculation, we have to have different decimals, or we can just do 2 and 2.
You always want to have at least 3 sig figs. So here, you could have done 27.7, then that would have been all right. Here you need to go at least, the zeros don't count, so you'd have to go at least 373, and that would be all right as well. But you have to give me at least 3 significant digits. So when you get to the first...
I'm talking about the second part, where we're finding y.
Yeah. Oh. So here, this, when you round it, if you round it to 3 sig figs, you get 65.0. So let me fix that. 0.0. Yeah. 3 sig figs. That's good.
Okay.
You're welcome. Thank you. Good question. The other thing to note, and this is really important, if I rejected H naught, because I rejected H naught, then I use the line. Because if you reject H naught, then there is a line, there is a correlation. If I did not reject H naught, I would not use this at all. Instead, I would have used Y bar, the average Y instead. Does that make sense to everybody? And I will ask you both those questions on the exam. I'll give you one situation where you reject it, and one situation where maybe I change your alpha, and I say, okay, well, what if the alpha is this? Okay. Here's some common mistakes people made on exam 3. The first most common one is that they did a proportion test when they should have done a mean test, or vice versa. It was really weird. People were doing that all over the place. When your problem literally says mean or average, that's when you have a mean. If it doesn't say mean or average, then it is not a mean. And that's how you know. A mean has to say mean or average, and has a standard deviation as well. Okay. So maybe that's the difference how you tell them to, well, yeah. ANOVA is obvious because it's 3 or more means. Okay. And then people, I think, a lot of times didn't realize the difference between X and X bar. X bar is a mean, it's an average. X is just, it's your frequency, or like your one, it's depending on situations, either the frequency, your number of successes, or it's just one value. It's not a mean. But you've got to know how to tell these apart. Again, if it says mean or average and has a standard deviation, it's a mean. Otherwise, it's probably a proportion. At least in terms of chapters 7, 8, 9. The other thing that people got confused about was the proportions. Proportion, I'm either going to give you X, the number of successes, or P, the percent. So here's your formula, right? The percent equals X over N. I'm either going to give you one or the other, not both, probably, usually. And you're always going to get N, but you're either going to get X or you're going to get P. They're not the same thing. So here, this situation here in red, 3 students, 8 Cs out of 9. 3 students, is that a percentage? Is that 3% of students, or is that 3 actual students, 3 successes? That's your X, that's your number of successes. So this would be your X. So if you want to find P, when you have X and N, you do P equals X over N. Over here in blue, 14% of students, 8 Cs out of 9. 14%, is that a percent, or is that 14 students? That is not 14 students, that's 14%, that's a percentage. So that is your P. Don't go putting 0.14 over 9. That's what some people did, that was crazy. This is your percent. So if you want to find X, for example, then you'd use this X equals NP, so it'd be 9 times 0.14. The other thing that people did very often was they got mixed up using the T table or the Z table when they should have used the other one. So if you were supposed to use a Z table, so here's how you remember. Mean Mr. T, If it's a mean, use the t-table, always. Easy peasy. Proportion, z. If you have a p, a proportion, use the z-table. So, people who mess it up on the critical value, if they use the z-table when they should use the t-table, or vice versa, they lost 2 points. If you use the right table but just picked the wrong number, then that's when you got the -1/2. On the exam, on the final exam, it's going to be more, because this is sort of your warning, right? Everything's going to be a little bit higher on the final for that. The other thing that people messed up a lot was, I said, input your answer to step 3 inside of this box, and then they stopped at that, and they didn't do any more steps. They didn't do steps 4 and 5. Give me the whole test. I want all 5 steps. The reason why I had you input step 3 was because step 5 is a lot harder to input. You got to type in a bunch of stuff, and you got to say, it's hard to get the same as well. Like, you have to say exactly, do not enough evidence, blah, blah, blah. If you have an extra comma in there or anything else, it's going to mark it wrong. And you also get limited on the number of characters you can type in. So it's a lot easier to have you type in step 3 and compare that to see if you're right or wrong, so you can kind of get a sense of how you did on the problem, than it is to have you type in step 5. So even though I have you type in a step, still do all the steps for all these hypothesis steps. Do all 5 steps. Same thing with confidence interval. Don't just give me the margin of error. I ask for the margin of error, but do the whole confidence interval. I ask you for the confidence interval. Yes, you're going to input the margin of error into the box, but then find the confidence interval, right? Parentheses, x bar minus e, comma, x bar plus e, whatever those numbers are. Those are the numbers. I need numbers in there. So go ahead and finish that out and find that. Okay, here is our first problem. Take a look at it. 4 college students work part-time. You randomly select 4 students. What's the probability that all of them work part-time? Is this likely or unlikely? Explain. What's the probability that none of them works part-time? Okay, so you might say, oh, binomial, and you're right. You totally could use binomial on this, absolutely, 100%. But this is even simpler than binomial. I mean, binomial will get you the right answer. It just be a little more work than this. Probably all of them work part-time. That means that the first one that means you're looking at probability that the first one's a yes, and the second one's a yes, and the third one's a yes, and the fourth one's a yes. So you want yes, and yes, and yes, and yes. What's the probability the first person says yes? 42%. What's the probability the second person says yes? 42%. Third person, 42%. Fourth person, 42%. Because remember, these are all college students, so grabbing a few doesn't change the percentage. So ands, 42% and 42% and 42% and 42%. Ands, we do what, guys? Ands, we, help me out, someone. Yep, multiply. Ands, we multiply. Right, so this is going to be 0.42 times 0.42 times 0.42 times 0.42. And if you do that, you will get 0.031. Now, is that likely or unlikely? So now we've got to go back to likely and unlikely. What's my guideline for unusual or unlikely? Anybody remember? What's my guideline for unusual or unlikely? 5% or less, exactly. So 5% or less. Is this 5% or less? Is that 5% or less? If you're not sure, then type it out. Give it the same number of decimals. 5%, 0.050. Give it the same number of decimals, and that makes it easier to compare them, right? It's harder if they have this different number of decimals. So yeah, this is totally less than, 31 is less than 50. So yeah, it is unusual. So this is unusual, it's unlikely, because it's less than 5%. What's the probability that none of them works part-time? None of them. So that's the probability that no and no, none of them. First guy says no, and the second guy says no, and the third guy says no, and the fourth guy says no. They're all no. Well, first I have to figure out the probability the first guy says no. So what's the probability of no? Probability that someone says no to me. What's that probability? Anybody? Yep. It's 1 minus probability to say yes. 1 minus 0.42, which is equal to 0.58. Good. So now, this guy says no, and this guy, and that guy, and that guy. And we do what again, guys? Multiply. Good. Good. So 0.58 times 0.58 times 0.58 times 0.58. I get 0.113. So it's not unusual, because that's definitely more than 5%. Okay. Good. I'll leave this up for 5 seconds while you guys take a look at it if you need to. And moving on. Oops, not there. So here's 2 problems. Here's the first one. Take a look at it. I have another problem to ask you as well. So take a look at this one. 4 digits, 0 through 9, followed by 2 letters. How many letters are there in the alphabet? 26. How many possible codes are there? And again, you can reuse letters and you can reuse digits. So I'm going to take a picture of this or write it down quickly. 4 digits, then 2 numbers. How many codes? And then I'm going to flash up this next one. So this is the first one. And I'm going to move it in 5 seconds. 5, 4, 3, 2, 1. Here's the next one. Oops. Nope. Don't look at that. There's the next one. So I'll leave it on here. Go ahead and do this problem too. I'm going to open your breakout rooms, do both of those 2 problems. I'll give you guys 5 minutes for those 2. That should be enough.